Hello everyone, Josh Hedstrom here. I just wanted to give a little demo video of how to use the Brain.js machine learning JavaScript library. I came across it a few weeks ago and I've really enjoyed it. It's huge, obviously, and there's a ton of stuff you can do. It has great documentation, but I wanted to kind of put together a little practical application just for anyone who wants to dig into it a little bit more and maybe doesn't have as much experience. So I'll have this link in the video description, but you can start off with just cloning my repo right here. Just navigate to whatever directory you want to do it in, and then get it cloned. Change directories into it. You're going to want to make sure that you have Node installed. You can check that by doing node tech-v, and that'll give you the version. So obviously if you don't have it installed, you won't come up with the version. In my README, I have the link right there to the Node download page. If you don't have it, if you're going to download it, you can just download it to the default settings. So I don't need to do anything fancy for this. NPM comes with it, which is awesome. And so then the next thing I'll have to do is install the dependencies. The only dependency really is Brain.js. So we'll do that. Yeah, and then start off with, I would probably just open it up in the text editor. Just kind of give you an idea of what we got going on. Yeah, so ml.js is kind of the main script file. So right here in line 1 we're requiring Brain.js, the library, the dependency that we just installed. And then line 2 we're requiring the data folder. So this is the training data. I got it off of UCI's website, which just has a lot of free machine learning libraries training. And yeah, there's a ton of wines on here. It's like 1600. It's pretty ridiculous. I mean, it's overkill for what I'm doing. I've probably overtrained it a bit, but this is just kind of a proof of concept video. So it starts off with, these are all of the factors that are going into the wine. I'm not a wine person, but evidently it makes a big difference. And then right here, it also lists the quality. So that's what we're training, is we're training these factors as the input and then the quality as the output. So like I said, right here we're requiring that array with all those objects. Line 6, this for loop, we're iterating through the array. And then we're pushing to the wine array, this as the input, and then the quality as the output. I had to divide most of them by 10 because the values need to be between 0 and 1. So yeah, so then line 30, we train the wine array. We train the machine learning algorithm against the wine array. Then for options here, I have it to set log as true. There's a lot of options. Brain.js goes into more detail. I've let the iterations stop at 2000. Or that's the default, so I've just let that be. And then the error threshold, 0.005%. And I'll go into that a little bit more. So yeah, so that's going to train against this data until either it hits 20,000 iterations or it hits the error threshold it's looking for. So then, after that, I'm going to run against that algorithm this as my input. So you can see this is all the factors of a wine except for the quality. And yeah, and then I'll just console log that. So I'll just run that. You can just type node and then the file name. So that'll run it. So if I hadn't set it log to true, all it would do is log, or all you would see is that line right there. So it looks like it only ran through the iteration 30 times, and every time it changed, the error percentage got a little bit better, and then on the third, or on the 30th iteration, the error got low enough so that when you round it up, or when you round it, it's right at 0.005. So for the factors that I input then in run, this is the quality that it gave me, 0.5. So on a scale of 1 to 10, it's about a 5. So I don't know anything about wine. I assume that's alright, I guess. But I wouldn't know if that's actually accurate or not. I know that there's probably more factors that go into wine than just these chemical contents. So yeah, so that's basically it. But now, you know, we can mess around with stuff. I have no idea, you know, if changing these levels, you know, makes it good wine, worse wine. Technically, you can take any wine that you find on the street, and if you happen to know all of these values, you can input it and come up with quality. So we'll just try that. Well, I iterated through 20 times, and it still said it wasn't a half bad wine, I guess, 5 out of 10. Can change the alcohol down to 1. Let's change let's change the pH to 9. See what that gives us. It gives us evidently a pretty terrible wine with a score of about 3 out of 10. And iterated through 30 times. So that's basically how you can do it. To get even more excited, I guess we can mess around and reverse it. So what I'm doing right here is I'm switching the input and the output. So basically, when I started off, we were giving the algorithm a set of factors, and then having it guess the result, and then giving it the result. The result being the quality. So now basically what I've done is I've reversed it. So now we're telling the algorithm if the quality is 5, these are the factors that go into it. And then again, if the quality is 5, these are the factors that go into it. If it's a 6, these are the factors that go into it. So I've done this already, and so I know what it's going to do. It's going to top out at 20,000 iterations. But you can see right here the error threshold 0.015. So that's about 3 times the error threshold that we had before. And I know it'll run through all 20. I will run through 20,000 iterations. I mean, I could change that and have it go more, but I'm not really that desperate for proof of concept here. But you can see, if you're watching these numbers, it is getting better and better. You know, not much, but it is getting a little bit better. But it'll never actually get to that 0.005 threshold. While we're letting that run, yeah, you can take a look at this file if you want. This is in the Brain.js. It's the browser.js. So this is like the entire, well, one of the files for running this in the browser, and it's 24,000 lines of JavaScript. I still kind of am. I'm about halfway through reading it, just trying to understand it a little bit. Obviously, it's super intense, and whoever made this was much smarter than I am. I'm just learning how to use it. So this is I'll have this all linked, but this is the data set that I used. So you just go to folder, and I used red. And I think it says here, yeah, it looks like this is just some Portuguese wines from one region in the north of Portugal. So, I mean, I guess I wouldn't use this training set to try and decide whether or not, you know, a red wine from France is any good, or a white wine, but, you know, for intents and purposes. And it looks like we finished 20,000 iterations, and again, not really that much better than it was before. And this is what the output was. With alcohol of 9, sulfates of 0.8, pH of 3. Yeah, I mean, citric acid looks like 0.7. So yeah, whether or not that actually makes a wine that tastes good and that I would like, I have no idea. But it's just kind of this is a proof of concept. So I would really encourage you to go to the UCI website. This is all of their data sets, 400 and some, on everything. I mean, it seems like every imaginable topic. You know, some are data sets from the 90s, some are from this year and last year. There's a lot on here, you know, and it's great to just mess around with and train against, and yeah, have fun with. You know, you can change any of the values in this, you know, and it'll output something. You know, so you can take these wines and look at the fixed acidity, the volatile acidity, citric acid, and use these three variables to try and figure out the residual sugar, you know, or the alcohol or the pH level. I mean, you can do anything, and that's the thing about machine learning algorithms is they're smart, but they don't have any knowledge necessarily of themselves. Especially this algorithm right here is feed forward instead of recurrent, which means it doesn't actually remember. You know, you have to run through the training set every time you want to get a result. And yeah, the results are only going to be as accurate as the data set that you put in. So for example, you know, if you put in an eye color and you know, what state you live in the United States, you know, it might find a correlation somehow and come up with an algorithm to predict, but is that going to be accurate? You know, probably not. But anyways, yeah, I hope that you are able to mess around with it, have fun. Hopefully this is helpful. If you have any questions, definitely let me know. You can put through an issue or a pull request or something on my repo. Otherwise, just comment down below on YouTube, or find me on Twitter, and I will do my best to answer any questions. And if you want to see more videos or videos of a different topic, just let me know. So thanks for watching.